Okay, this is a fairly standard question of an implicit differentiation problem. So we have an equation in which y is defined implicitly in terms of x. So we have the x and the y all combined together in the definition. We don't have an explicit y equals, and we're asked to find the rate at which y changes with respect to x and the second derivative of y with respect to x. Okay, so how do we deal with this? Well, we go through each term in the equation one at a time, and we differentiate with respect to x. So what do we get? Well, we get d by dx of y squared plus d by dx of xy equals the derivative of 3x. Well, I can just do that, and the derivative of 1 is it's constant, so that's just 0. Okay, so if things are just in terms of x or constants, we can just deal with those. Now what do we have left? Well, we have an expression here which is in terms of y, so we need to differentiate that with respect to y, but we want the result to be with respect to x. So using the chain rule, if we multiply that by dy by dx, we haven't changed anything. We've got a dy and a dy which will cancel. So we'll deal with that in a moment. The next thing, we've got a product here. X and y are both functions. So we're going to get d by dx of x times y plus x times d by dx of y equals 3. Okay, now let's deal with the things that we've got. The derivative of y squared with respect to y is 2y. So we get 2y dy dx plus d by dx of x is 1, so we're just going to get a y from that, and from this term we're going to get plus x times dy by dx. That's just dy by dx written in a slightly different format, so we get that. So we found an equation which involves dy by dx, x and y, so we just need to rearrange that, and then that will give us dy by dx. Okay, so take everything which doesn't involve dy by dx, which in this case is just this y, across to one side, and then factorize everything else. So we'll end up with 2y plus x times dy by dx. I'm doing a couple of steps in one here, equals 3 minus y. So I've taken the y across and I've factorized out the dy dx from those two terms to get that. And then I just need to divide, so dy by dx will be 3 minus y over 2y plus x. Okay, now to find the second derivative, I can just differentiate this. This is a fairly simple quotient, so I'm just going to use the quotient rule on this, exactly as I would before. But again, you have to do things term by term. So the quotient rule has, I'll let u be 3 minus y, thing on the top, and I'll let v be 2y plus x, thing on the bottom. So du by dx will be, differentiate 3, it disappears because it's a constant, differentiate minus y, and we'll get minus y dx. So the du by dx is actually minus dy by dx. Seems a bit confusing to start with, but you get used to it after you've done it a few times. And dv by dx, if I differentiate this, I'll get 2 times y dy by dx, right? 2 times dy by dx. And if I differentiate the x, I get 1. So I've got these two terms here, which I need to put into the usual formula. So now d2y dx squared will be, was it v du? So it's 2y plus x times minus dy by dx minus u times dv, that's 3 minus y times 2 dy dx, that's 1, all divided by v squared, which in this case is 2y plus x squared. Now that all that's left to do is I need to replace the dy by dx with the expression from above. and it gets very messy. So I'll just write this out. What is it? 2y plus x times, it's minus dy by dx. If I do the negative of that, it just means flipping the top round, so it would be y minus 3 over 2y plus x. Oh, get a cancellation there, so I could simplify that slightly. And minus 3 minus y, and it's 2 dy by dx plus 1, so it's 2 times 3 minus y over 2y plus x plus 1, all divided by 2y plus x squared. There might be some simplification in there. I think there's probably some common factors. You could probably take out this top line, but if it's an exam, then it's probably just going to introduce errors. If you're asked to find it at a particular point, it will be at this stage that I would start substituting in values. So there's the first derivative, there's the second derivative.